Years at Google rebuilding the infrastructure behind the world's largest atomically versioned source code repository. Today, David is going to be telling you about next steps in scaling Meteor.
Sorry, one moment. All right. There we go. All right. Hi, folks. Yeah, as Jade said, my name is David Glasser. I work here at Meteor on a variety of things, but most recently I've been spending my time on the way that Meteor works with its database. Specifically, I've been working on, and I'm here to tell you about how Meteor makes MongoDB real-time via oplog tailing. So, if you've played with Meteor, I think it's safe to say that the big feature of Meteor, the big thing that got people excited when Meteor was initially released a year and a half ago, was that Meteor makes real-time the default. When data changes in your database, anyone who's looking at any web app that has that database immediately updates automatically to show the new data without having to write any custom code for that specific query or that specific bit of data. There's a lot of other cool things about Meteor that I like, but honestly, I think this is the big feature of Meteor. And it has a lot of layers that work together to make this work. But I'm here today to explain a little bit about how the Meteor real-time stack actually works and how we're going to make it perform better. So if you've made a Meteor app, you've probably written some publish functions, right? So any client decides which record sets it wants to subscribe to, and it sends a subscription request to the server. The server runs a publish function, which is just a short little function in JavaScript that you write yourself. And usually what it does is it takes some parameters and it makes a cursor to the database, such as in this case, that's the scores.find. It does some sort of database query, and then it returns that. The server watches that query. It publishes the data that's in that query right now, and it keeps watching it as it changes. When changes happen, the server sends data messages to the client using our DDP protocol over WebSockets. The client updates its local cache, that's its mini Mongo, its in-memory cache of a subset of the data that the server has. And then when changes to the local cache occur, Meteor UI re-renders the templates. It's true that there's a lot of steps here, and that's because we've designed Meteor as a layered system, pretty modular, made out of a bunch of components. But each of these steps are actually relatively simple and straightforward. For example, when we see a change happen, sending a message is pretty straightforward. You just format a message. It's a simple JSON thing, goes over the network. Client updates its cache. And even the thing that seems magic, where changing the cache makes the template re-render, is not as magical as it seems. Basically, whenever a template is rendered and it reads some data from the database, essentially it remembers this template dependent on this bit of data, and so when that document changes, re-render the template. But there is one piece in this stack that is actually kind of complicated or kind of exciting, and that's the very sort of middle step there, the step where we actually find that data has changed in the database. I mean, how does that happen? I mean, if you've written normal applications with databases, you know that you can connect to the database, you can do queries, you can write to it, you can, et cetera. But usually, run a query and then keep running it forever and tell me as it changes just isn't the thing that a database has. Most databases aren't real time like that. So what we've done in Meteor is we've added a new API to the Mongo database. We call this API Observe Changes. So in our perspective, Observe Changes takes Mongo from being sort of a static database to a real-time database. So in addition to being able to say, I'd like to do this query and fetch the results, Meteor lets you say, I'd like to do this query and observe the changes on this result over time. The interface to observe changes is you specify a cursor and you say, I'd like to observe changes on this. This is my function to call when something gets added. This is the function to call when something changes. This is the function to call when something is removed from the results. When you first call it, it calls the added callback on all the things that initially match the query. And then it continues to watch it and see as it changes and call it. Now, many Meteor users happily make Meteor apps and never type the word observe changes themselves. But it turns out that every time you return a cursor from a publish function, which is sort of the most basic read operation that you do in Meteor to read from a database, it's actually calling observe changes from behind the scene. And so because of that, this one function is what I have actually probably spent more of my time working on this project paying attention to than anything else, despite the fact that most Meteor users might not even know it exists. So one interesting thing about observe changes is observe changes supports all Mongo queries. What we're doing is we are taking the full query API of a real database, MongoDB, and making it into a live query API where we can both find out what the results of a query is and see it as it changes. If you've made your own real-time web app from scratch, you've probably found yourself sort of writing this a lot of custom ad hoc code where you say, okay, well, I'm showing a post and some comments, so I definitely want to keep checking to see if there are new comments on this post, or maybe when a new comment happens, I have to figure out which users are looking at that post, and then I have to tell those users that there's a new comment, and but then the comment changed, and you end up having to write a lot of this ad hoc code. And with Meteor or any real-time database, you don't have to do that. Now, there are other real-time databases out there. Firebase is a pretty cool example, but a lot of the other real-time databases have made the choice of having a very restricted set of queries you can do, such that it's relatively easy to implement them to become real time. And we've said here, well, there's a reason that Mongo has this API, this set of queries you're allowed to do, this set of selectors. It's because they're useful, and people writing web apps want to be able to do all these different kind of selectors, all those different dollar operators that Mongo has, all the different options you can pass. They're useful, and we don't think that the right thing in Meteor to do is say, sorry, you only get a small subset of queries, hope you laid your data out exactly perfectly. We think that app developers want to write apps. They want to think about their data model, they want to think about their UI, they want to think about workflow. They don't want to think about low-level, or I'm guessing for many of you, don't want to think about low-level data flow, cache invalidation, concurrency logic. I want to think about that because for some reason I think it's more fun to think about low-level cache invalidation database logic than writing an app. You should see the app I wrote a couple of weeks ago. It works, but it's really ugly. And but I think that that should be my job. And you, as a user of the Meteor framework, unless you're really inspired by it and want to send pull requests to improve it, you should just get to write a query and have it work. So how does observe changes work? Well, the initial implementation of observe changes that came with the first publicly released version of Meteor, and as the backbone of how every released version of Meteor so far, uses an algorithm I'd like to call pull and diff. It's pretty straightforward. And basically, if we want to know how the results of a query changes, well, we run the query. And then later, we run the query again. And we look at the two answers, and we see what changed. And we say, oh, that thing changed. That document wasn't in it before. I bet I should call the added callback. And this document's not in it anymore. I bet I should call the removed callback. And this document was in it both times, but one of the fields changed. I bet I should call the changed callback. And you can actually get a pretty simple implementation. This is pseudocode, but this is basically, at the core, how pull and diff works. It really is just ask Mongo over and over, hey, what's the answer of this query? And figure out what changed. So there's some subtleties to this. The big one is, when do we rerun the query? Well, one answer is, we should rerun the query, we should pull Mongo again, anytime that we think that the query might have changed. So when do we think the query might have changed? Well, the most obvious way that we would think the query might have changed is if we were actually changing the database ourselves. So anytime your Meteor server does a write to some collection, like the scores collection I had in that example, the pull and diff algorithm says, wait, the scores collection changed. Every query that I'm running on the scores collection might have different results now. Let's run the query. Let's pull them all again. Let's rerun all these queries. Additionally, though, there might be some writes that happen not inside this server process. Other you are running more than one Meteor server process because you're doing some horizontal scaling. That's pretty likely, actually. In order to detect the writes that come in from other Meteor servers, you can't just, that trick doesn't work because they're not in the same process. Or maybe your database is not just being used by your Meteor app. Maybe it's being used by a bunch of different Meteor apps, or even something you wrote not in Meteor for some reason. And maybe you would like to see how the database changes from external sources. So in addition to polling your queries when we change some data, we also just throw in every 10 seconds, let's repoll each query again. And so that catches writes from other processes. So what's good about poll and diff? Which again is basically how Meteor observed changes, which is to say Meteor live database reactivity has worked for the past couple years. Well, one big benefit is that the code is short and it's correct. It works. Nobody is reporting bugs to us the wrong data is published from my queries. And that's really important. I mean, this is database APIs we're talking about. This isn't some machine learning thing where there's a 95% chance that we're classifying some photograph as as this type of animal correctly. There's a correct answer to database queries, and if a database API starts returning the wrong things, that's a problem. I mean, performance is important too, but in my opinion, when it comes to database APIs, being as close to 100% correct as you can is pretty important. You might have to define correct, in the way that you like it, but it's pretty important that your APIs are actually correct. And it's pretty easy to read the poll and diff code and convince yourself that, yep, that asks the query over and over, and then it finds the changes. One other nice thing about it is that writes that happen inside the current process really are reflected on clients basically immediately, which is the magic of Meteor. You change something in this browser window, and everyone else in the room or the world sees it too, pretty much immediately. And also, because we do this 10-second poll, writes that come from other processes are reflected on clients eventually. I mean, 10 seconds, it's close to real time. It's not as real-timey as immediately, but I've certainly used web apps that where if you change the database not through the web app, it just never notices that it's supposed to send you the new data without having to hit refresh, even though they're supposed to be real-time, no refresh required apps. So poll and diff does actually work. But there are definitely some drawbacks. I would say there are basically 3 classes of problems with poll and diff. So number 1 is about polling, number 2 is about diffing, and number 3 is the thing we actually already talked about. So number 1, it has a performance cost that's proportional to the frequency that you poll. So specifically, the more writes are happening in the database, the more write traffic you have, the more often you're polling because you're being told all the time, oh, something changed. Let's check to see if it's changed. Oh, something's changed. Let's check. And so the more write traffic you have, the more Meteor and Mongo CPU and Mongo bandwidth you end up spending on repolling over and over and over, even if maybe you're polling things that are not really related to the thing that actually changed. The second problem is that the cost of a diffing is proportional to the query result size. So even if data isn't changing very much, let's say that one of your publish functions is publishing 5,000 records, and maybe one of them changes every few seconds. Well, what does polling actually consist of? Well, it consists of going to Mongo and saying, hey, Mongo, run this big query again, do all that work to rerun the query, and find 5,000 elements in your memory, serialize it to BSON, which is Mongo's wire format, put it on the wire using up bandwidth, send it to me, the Meteor process. Then the Meteor process has to go and deserialize the BSON, which takes some time, some CPU also. And then it has to take the last 5,000 results and the new ones and do a recursive diff looking at both of them. And none of these are super complicated, but it adds up. And if only a little bit of the data is changing, a lot of that work is kind of wasted. But of course, you only know which part of the work is wasted once you've done the check. And finally, there's the thing I already mentioned, which is that you get pretty low latency, very real-timiness, when the write is in the same server as the observe. But when the write to the database comes from outside that server process, you have to wait up to 10 seconds. So the first thing we did is to try to improve the performance here is to basically optimize poll and diff. rather than throw out poll and diff and start over. And we specifically focused on number 1 here, the issue of we're just polling way too much. So we did 2 optimizations about a year ago. These are actually some of the first projects I worked on when I started working on Meteor late last year. So 2 optimizations are, well, I've said that, well, when we do a write to a collection, we need to look at all of the queries we're observing on that collection and rerun them in case it changed. But we know what the write we did was, and we know what the query is. So maybe we can actually look at the write and look at the selector, look at the query, and analyze them and say, there's no way that this change can affect this query. And if we do that, we can just skip the poll. So specifically, we implemented this for the common case where you're writing to a document with a specific ID, and the queries are reading a specific ID or a specific set of IDs, because that's pretty common. Like you have a publish function that takes in as an argument an ID, and it publishes the document with that ID, and you have writes that are update this particular document by ID, setting this field. And if the IDs are different, you know that this is not going to affect that. You can skip the poll. We could probably have also done more complicated analysis on more complicated selectors and writes. And in fact, we've done that as part of the new project that I'm going to get to soon. But we didn't do that at that time. The other big change we made last year was query deduping. This is essentially a caching thing. The idea is that, everyone's going to your blog, and most of the people going to your blog are just going to the front page. They're all looking at basically the same data. They're all subscribing to the 10 front page stories and the 3 links in the top left corner and the 5 of these. And you really don't need to have, for every single user, every single connection to your site, a separate little process going on inside your server saying, oh, I want to know about the top 10 blog posts on my site. Let's keep asking Mongo if those changed. You really need one of those that should be shared among all the connections to your server. And so especially this is useful when there's commonly requested data that doesn't depend on the user who's logged in. But even if it does depend on the user who's logged in, you open 20 tabs, they probably share some stuff too. So we implemented basically a live cache that does deduplication in Mongo. It turns out that implementing a cache of a process that is that is itself caching data and calling callbacks and watching stuff is more complicated than just implementing a cache that is just, what is the answer to this question? It is this. We had to do a bunch of stuff with adding some new primitives, essentially, to node concurrency primitives to make sure that we didn't have weird race conditions. And that seems to have worked pretty well, too. So these 2 optimizations basically worked on the first issue here, the we poll too much problem. But they didn't help with the fact that diffing a big thing takes a while and also takes a bunch of bandwidth from Mongo. And it didn't do anything to deal with the fact that writes that happen outside this process take 10 seconds to show up. So poll and diff got us this far. Well, what's next? Well, the answer is oplog tailing. So we've been working for the past couple months on implementing a new version of observed changes that's built on top of oplog tailing. And I'm pretty excited to talk about that now. So what is the oplog? I mean, that's not even a word. Well, if you're using MongoDB, you're probably using multiple MongoDB servers so that you don't have a single point of failure if your database goes down. You probably have a primary server and a couple of secondary servers. And the primary server is what all your writes go to and most of your reads. But the other secondary servers are sitting there trying to make sure that their database is exactly the same as the primary's database so that if the primary goes boom, one of them can say, oh, I'll be the new primary. And so how does that work? Well, this replication used as a log, like a list of all the operations that are happening in the primary. So the primary is basically spitting out all the time something that the other secondary servers subscribe to and listen to, kind of like DDP. Basically a log that says, this document got inserted, this document got updated, this document got removed. And it's basically a real-time feed of all the low-level changes inside the database. And it's designed for replication. It's designed for this primary, secondary replication. But it turns out that it's implemented just as another Mongo collection, and you can write your own code that also tails the oplog. You can follow along and find out about every single change as soon as it happens in the database, which sure seems relevant to our API observed changes that wants to find out about changes to queries. So what we've done is we're using oplog tailing to implement observed changes instead of polling over and over. We're going to let the database tell us what changed instead of just standing to the side and being like, I wonder if something changed. Hey, tell me from scratch everything you told me last time. Oh yeah, that was the same thing again, thanks. No, we're just going to wait and let the database tell us what changed. So I'm going to walk through a little example here, sort of conceptually. So I hope you can read this. The query we're going to do now is we're going to be searching in the scores collection, which is some sort of collection of scores for various names of various people. We're going to be, our query is game:karam, so we're only going to be looking for scores for the game of Karam, which is a game we enjoy playing over lunch here at Meteor. We're going to sort the scores, descending by score and limit 3, which is to say we're going to ask for the top 3 scores, and we're going to publish the fields score and user. So what do? Well, first we actually just run the query. We just say, hey Mongo, here's a query, run it, just like we start out with the poll and diff. And it gets back and it says, okay, here are the top 3 scores. They're Avital, Naomi, and Slava, 150, 140, 130. We cache this in memory, and then we start looking at the oplog. And so what we're going to do is we're going to be seeing a bunch of events that come across the oplog, like insert, update, and remove operations. And we're going to have to look at each of these operations and figure out how they affect the results we have so far of the query, and update our cache, and possibly fire some events that say, hey, something got added, hey, something got changed. So for example, the first event that comes through is this insert. So a new thing is being inserted. It's a score for the game of skee ball. But our cursor is searching for the game of Karam. So there's no way this event is relevant. So we can just ignore it. Next. All right, next up, we still have the same cache, still have the same query. The next operation is also an insert. This time it's for the game of Karam. Okay, so it does match our selector. It's a score by me, Glasser, and it's a score of 10. Definitely not the top 3. Next. All right, next up we get a remove event. It's removing this element by ID. Everything on the oplog is named by ID. Well, this PPP, I've never heard of it. It's not one of the 3 things we're publishing, and we don't have a skip defined. If we were using skip, then it might be one of the things that came before the things we're publishing, but we're not doing that. So this is irrelevant. We can just ignore it, right? Next. All right, how about this one? This is an update operation. It's updating some score whose ID is CCC. That's some other score I've never heard of. And it's saying it's setting the color to blue. I'm not really sure why scores have colors. I'm colorblind. It's not really my thing. But anyway, this seems really irrelevant, right? It's not one of the things we're already publishing. It doesn't have anything to do with the selector. Like, the selector is about what game we are. This isn't going to change whether or not something matches. It's not going to change where it is on the ordered list. So it's great that something changed in the world, but we really don't care. So we can just ignore this one. Next. All right, the next one we get an update. This is an update to ID XXX. Wait, that's actually one of the things we're publishing. That's that 150 Avital score. And it's setting the color to red. Well, that is a change to one of the documents in our cursor. That's better than anything we've had so far, or at least more relevant. But color is not one of the things we're selecting based on. It's not one of the things we're sorting based on. And it's not one of the fields we're publishing. So even though it's actually the same document we care about, it doesn't actually affect what we're publishing. So we can ignore this one too. Next. All right, here's another update. This updates document DDD, another document that I've never heard of before. And it sets the game to Dominion. So last one of the ones we skipped before was setting like the color of something we've never heard of before. And I said, well, that has nothing to do with any of the relevant fields. This has to do with one of the relevant fields. I mean, the selector is selecting based on the game. But there's no way that setting the game to Dominion is going to affect our results, because it's impossible, because we're only looking for things that are Karam. And it could be that this document was already Karam and we were taking it away from matching, but it's not one of the 3 ones we had published. So who cares? Next, I promise there'll be something relevant eventually. OK, here's another operation. Well, this operation is an update. It's an update on XXX. Again, that's the first one there. It's Avital's score of 150. And it says, change the user field to Avi. OK, I guess he changed his username or something. So that's actually relevant. That's one of the things that we're publishing, and it's even one of the fields on the document that we're publishing. So great. What do? Well, we actually send the DDP message over the WebSocket. We call the changed callback. We say, ID XXX, set the user field to Avi. This probably gets sent over the wire to a browser client. It triggers some depth stuff. Meteor UI finds every place on the screen that was showing the username of this score and changes it to Avi. And we update our cache That's the thing I've been showing at the top. So now the cache contains the new value with avia instead of avital. Next. All right, the next thing we got on the oplog, I'm excited about this, is a new score. It's a score in the game of Karam, so it matches. It's mine, user Glasser, and it's score 200, which is definitely more than 150, 140, or even 130. So that means that this is actually now going to be the new high score. So we call added. We add this to the to the query. We call removed on the bottom one because we're only allowed to have 3 at any given time. So that sends 2 more messages over DDP and updates the whatever UI is showing this. And now we have a cache that shows these 3. One more. Now this one's a little trickier. We get an update to yet another document I've never heard of before, EEE, and it sets the score to 500. Well, is that relevant or not? It's actually kind of hard to say. If this EEE document was a Karam score, maybe we're just adjusting the score for some reason, it was entered wrong originally, then that's the new high score. It's like more than twice the current high score. On the other hand, if this is just a skee ball score or something, then, well, it's not particularly relevant. So there's really only one way to find out. We actually have to go to the database and say, give me a little more context, like give me the rest of the document, or at least some relevant fields of the document EEE. And if Mongo comes back and says, hey, here's the EEE document, and guess what? It is a game of Karam, then great. We'll call added on that to add a new top score. We'll pop off the old third place with a removed. But otherwise, if it's not a Karam score, we'll do nothing. So what I'm trying to say is that when you're processing the oplog, there's various different things you can do. Hopefully you could ignore most of what goes past, because probably most things that happen in the world are not relevant to the little thing you're trying to do right now. I mean, that's just true. But hopefully you can skip most of the things without doing any extra work, and then hopefully the things that are relevant, you can, in most cases, immediately figure out, oh, that's relevant, great, this is the change that happens. But in some cases, you have to do a little extra work and ask Mongo for more context. But there's one thing about this whole process I've just shown you that differs hugely from poll and diff. In order to do that whole thing I was just explaining there, I actually need to understand how the Mongo query language worked. I need to understand what selectors were. I need to understand what field specifiers were. I need to understand sort specifiers. If this was a more complicated example, I would need to understand how all of those things work when there are arrays in there and nulls and all sorts of weird edge cases that are sort of documented by Mongo, but not really. This wasn't the case for pull and diff. With pull and diff, we got some query the user typed in, we shoved it over the wire to the Mongo server, and the database server did what it does best, which is understand its own language and process it. In order to do this oplog tailing, we actually have to implement from scratch our own JavaScript interpretation of how Mongo queries work. Conveniently, we actually already did that. Conveniently, we actually just happen to have, sitting around in Meteor, a complete Mongo query engine. It's what we use as the local cache on the browser. So we can basically just take that code that we used to only run in the browser, run it on the server instead. Now, we need to be careful because, as I said, the Mongo query interface is pretty complicated and not super well specified and has a lot of weird edge cases. And if we got those wrong in Mini Mongo before, all it meant is that, OK, your app looks bad for users, some bug happens, OK, but it's just something happening in the client. When we're now taking that code and running it trusted on the server and using it to decide what data to publish over the network from the database to the whole world, well, now suddenly bugs in Mini Mongo turn into security holes. So while we do definitely want to just not have bugs in Mini Mongo because bugs are bad, we want to be very careful about making sure before we trust Mini Mongo to process any specific query that we want to observe using oplog tailing, we need to be really, really sure that there are no bugs in Mini Mongo's implementation of that. We try to be very conservative about that. So we've run some benchmarks on this. This is not just a theory. This is real. We've implemented this. Nick has run a bunch of benchmarks with high write loads. And one of these benchmarks that was mostly full of inserts, not as many updates, we were actually able to scale to 10 times more connected clients than the original implementation of pull and diff. And that was a month or two ago before a lot of the improvements that we've been working on have been made. There have been a lot of improvements done also by Slava, who works at Meteor, who's basically added a whole bunch of stuff to Mini Mongo to be able to answer questions like, is this selector and this modifier, do they affect each other, which we didn't have before. A second benchmark that has more updates, which are a little harder for oplog tailing to handle, still got us up to 2.5 times more connected clients. And again, that was before a couple latest rounds of heuristics. Our goal here is to scale Meteor so that Meteor CPU, Meteor is not the limiting factor. We want to be able to scale it so it gets every little bit of juice out of your database, and that's the limiting factor. And actually with our benchmarks, that's what we're seeing now. We're seeing that Mongo server CPU and bandwidth is what limits us, which there are two great ways to work around. Well, one of them is just that we have more ideas of ways to improve oplog tailing that will involve fewer queries to the database, which will ease some load on it. The other way is that we can actually do our reads from Mongo replicas, which we can just run more of to take load off of the main Mongo server. And the cool thing here is that usually when you fall back to secondaries for your reads, you're worried that you might get something stale. But when you're watching a live query, it's okay if you get something a little stale, because you're going to keep paying attention and see the not stale thing in a moment anyway, which is pretty awesome. And so I'm happy to announce that oplog tailing has been merged to Devel, which is the main development branch of Meteor today, this morning. Right now, it's only turned on for a subset of queries, specifically equality queries, so no $sign operators, and we do not actually support skip, sort, and limit yet, as I was showing in the example. But we plan to support a whole bunch more queries before 1.0, where this should get out in the next release of Meteor, the initial class of queries. The current implementation runs automatically when you just run your app in dev mode, on Meteor run or Meteor with no command. That uses oplog right now in Devel. And if you want to use it in production, just set up your Mongo database such that you have access to the oplog and set the Mongo oplog URL environment variable. It works with Galaxy, which is our successor to Meteor Deploy that I think some of you know about, which is what we're running a lot of our internal apps on right now. There are apps running in production that we use internally at Meteor that are using oplog tailing for all of their stuff, and it seems to work pretty well and scale well, which is pretty exciting. So I'm really excited to get this release out with the limited oplog support and have people start using it in production and get more feedback about which features we should focus on supporting next, which queries, et cetera, getting more profiling data so that we can really move on to this next stage of scalability for Meteor. So thanks so much. Any questions?
So if we fast forward to the future when all queries are sorted by oplog, are there appreciable performance differences in the queries? Like, should we really care if we're going to use like $in, or should we try to structure things in some smart, performant way?
Well, I think if we actually are, so what James was asking is if we fast forward to a future where everything is based on oplog, do we still have to care about how we write our queries? I do think that at the end of the day, look, no database is 100% magical. There are always going to be queries that perform better or worse, even just in Mongo underlying, let alone in Meteors. And there will probably be tips and tricks you have to learn. I think we're going to learn what those tips and tricks are by actually, finishing the implementation of oplog and actually getting more outside of Meteor development group experience using it. I think there probably will be a period where there are tips of like, okay, if you use these, it'll trigger oplog and it'll be great. And if you write it this way, it won't use oplog and that's not great. But yeah, I think we're going to learn that together.
So what is the runtime performance difference between using oplog and not having it?
So you're asking what the runtime performance difference is. Do you mean sort of an abstract sense or in like actual numerical sense, like benchmark-wise? I was just saying, what we were able to scale one of our benchmarks we were working on to, and this was again before the last couple weeks of really focused work, to like 10 times more clients and another one to 2.5 more. And that was a pretty heavy write load benchmark that I think is a lot higher write load than most real apps are these days.
Leonardo?
I remember hearing a couple months ago, you guys weren't really sticking to one database or the other. It kind of sounds like you're going full force with Mongo versus a different database.
Yeah. So the question was about like, are we focusing on multiple databases or just focusing on Mongo? I think the answer is yes to both of those. I mean, we've always designed Meteor to be pretty modular. Like everything that knows about Mongo is in one particular package in Meteor, the Mongo Live Data package. There's nothing stopping people from writing other database implementations, and people have in fact been doing it. You can find all sorts of Rethink and Redis and this and that, the other on Atmosphere. That said, we're also still learning about how to make Meteor apps better. We are changing lots of things as we approach 1.0 about how Meteor works, and we don't want to be tied down by, oh, we have to make everything work on 5 different databases and update that. Like as Jade mentioned, I used to work on Subversion, and the experience there was, well, Subversion had like 3 wire protocols and two file system formats that it had, and anytime you wanted to add any feature, you had to like add it basically to the the HTTP DAV wire protocol, the custom protocol, the local file system protocol. Then you had to implement it both for the BDB back protocol and the like flat file back thing. And like by the time you've done all that and tested it on like all 10 combinations, well, that was great for a pretty stable project like Subversion 1.4 or whatever, but like that's not how to move forward fast and like get to 1.0. We're keeping our design such that you can use other databases, but we really want to be a really, really great solution for one database rather than a decent solution that you might want to use for like 7 databases. But especially once we have once our APIs get more crystallized around 1.0, I think it'll be really exciting to see what happens. And a bunch of us keep talking about, oh, I'm just gonna, not show up to work for 3 days and like write a good Redis model that's module that's like actually supportable. I want to actually add one thing that I forgot to mention during my talk. One other thing people might know about oplog tailing, and speaking of third-party contributions to Meteor and Atmosphere and so on, is that Aranota Sasarella wrote this thing called Smart Collections a few months ago, which was basically the first actually usable by people implementation of using oplog tailing for Meteor, which was really exciting. And I did a bunch of code review for him, and I actually also, we basically, a lot of knowledge passed in both directions there, and some of what we've written is really takes a lot of inspiration from his stuff, and vice versa. And it was great being able to work with him on that. And I know he's excited about seeing this be in Meteor Core as opposed to just an external package.
What sort of attention are you going to, or priority are you going to be giving to this over the next few months in terms of adding to what you've already built?
Yeah, that's a great question. What sort of attention are we giving over the next few months to this? Yeah, as people who have been paying attention to Meteor knows, we are a company with like pretty big goals in terms of the scope of what we want for our project. And at any given time between now and 1.0, we have a bunch of different projects we want to work on, and only so many people that we are hiring. And yeah, it often has been our pattern that like we get something out and then we say, okay, great, now that this is out, we can work on the next project. But despite the fact that there will be a release containing oplog in the next few weeks, I am planning to continue, and I think Slava as well, to continue working on it. This is not a like release and quick switch to another project thing. It's a ongoing development for the next few months.
Before
situation.
we call you, Mark from British Columbia had a question on Twitter. Is the oplog cache in a Mongo collection, or is it small?
I'm not, sorry, the oplog cache?
Yeah, that's what.
I mean, oh, it's in memory. The stuff I was showing as the cache there is in memory in the server, which is actually an interesting point. One of the other possible next steps for this is something we've been talking about for a while, and that'll actually Galaxy is going to help with, because Galaxy makes it really easy to run more processes in your Meteor app, is that taking all this calculation, the stuff I showed you in those 10 slides of like, look at this, what do we do? Taking that out of the main Meteor server and moving into a separate process or many separate processes is going to be a good way to scale, so that doing all this calculation and following the oplog should not be like in the same single-threaded process as serving your index.html to users. And so that's definitely another approach we're thinking of. Eventually, that's definitely going to happen. The question is like sooner or later. Certainly, like it's easier to spawn new jobs in Galaxy than in not having Galaxy. So, hey Matt.
So the initial query result comes from running a Mongo query. The oplog is a different connection, right? So I'm curious, how do you figure out how those two things line up?
Oh, so Matt was asking about the one line in my slide that I skipped over, which is synchronizing between the initial query and oplog tailing is very subtle. So that's right. So it's not the case that observe changes is literally just tell me about changes to this query. It starts with saying, Mongo, run this query, and then continue asking them then continue telling me what happens. And it turns out if you don't do this carefully, there can be race conditions right there. I mean, I described it as first you run the query, then you start looking at the oplog, but like where do you look in the oplog? Mongo doesn't actually, since the oplog isn't designed for doing this, it doesn't really give you the way to say like, I want to start in the oplog at the exact point in time that corresponds to immediately after my query ran. In fact, the concept of immediately after my query ran doesn't actually exist because like queries in Mongo are not actually atomic across the entire set of documents. They're just sort of atomic on a single document level. So we actually have a bunch of sort of concurrency code that makes sure that like that we have a good idea of this part in the oplog is after all the things that went into the query, and if stuff is changing like at the same time you're doing the query, make sure you don't miss that. And that took a bunch of work.
I'm sorry, so I just wanted to try and clarify. You're building the oplog dynamically inside of the memory of the server.
So the question was, we're building the oplog dynamically in the memory in the server. So the oplog is something that is just part of MongoDB, as long as you've configured your MongoDB to be in replica set mode, which is basically what you do for any production deployment, because otherwise you have a single point of failure. And so the operation where the database has a thing you can listen to that's like, here are all the changes, is just something that Mongo does. And you can just connect to it and basically, it's slightly harder than it should be, but you can basically say, give me these things as it happens, sort of like connecting to a DDP server, a Meteor server, and saying, show me things as it happens. Then for each query we're observing, we also have a cache in memory of the results of that query at that point. I mean, we have one of those for pull and diff too. I mean, that's how it's the left side of the diff. But each query has sort of this cache of, this is the answer to this particular query. We're not trying to cache the entirety of the entire database in memory in your Meteor server. That would be a lot. Though we could actually like err on the side of like caching some extra stuff that like used to be in a query but isn't in a query right now but might be soon. But yeah, did that answer your question? Yeah. We're consuming the oplog, we're not producing it.
David from Australia had a question on Twitter. David says he's interested to know if these coming changes may lead to simplified joins in publications.
I think that is something we are very excited about building. Possibly not before 1.0, just because there's a lot of things we want to do before 1.0. I think that's like orthogonal. I think that the support we're going to build for joins will perform better because of oplog, but I don't think that's, yeah. I think that joins will be built on top of observed changes, essentially.
And Pallavi Anderson, captain of the Chicago Meetup group.
Oh, Pallavi.
Yeah, has a question. Will MongoDB make query or collection observability native?
That's a great question. So I have not actually like spent much time talking to Tenjin, or I guess they're MongoDB Inc. myself, about being able to bring this native. It's actually true that like I spent a lot of my time working on this, thinking like, you know, this is great and this is clearly the right thing to be working on right now, but are we going to be still using this code in like 2 years or 3 years, or are we actually going to have to move on to something else? And because a lot of the stuff that makes the oplog stuff difficult or adds extra overhead to it is that step that, if you remember that step where we see a change happens, but we don't have enough context to know if it affects our cursor or not, and we actually have to go back to Mongo and ask for it. It turns out that, you know, when like a Mongo slave, or sorry, secondary is reading the oplog, it does have that context. Like if you are the Mongo secondary yourself, you have exactly that context. You don't need this extra round trip. Also, it just turns out that like JavaScript is great. I really like it, and V8 is very optimized. But like there are some things that languages like C++ are better at, specifically just giving you like const, so you're not doing like crazy copies everywhere or having to like write in your docs, by the way, please do not modify any of the things passed to these callbacks. Like all those layers in that set of 5 layers does like a set of like, do a complete recursive clone of the thing I got because I need to save a cache of it. And I suspect that eventually we might want to do something where we actually add a feature to Mongo where we basically implement observed changes inside it, which would allow us to not need that extra round trip of give me more context. Of course, that means that then in production you have to run our fork of Mongo, or maybe this extra feature that we work with Tenjin on or something, and that's a lot harder than running stock Mongo. And adds a lot more to your like build complexity. So that's not what we built first, but it's possible that one day that's what we'll need to build. And then you don't have to worry about the we re-implemented Mongo logic from scratch issue, because we just would use, you know, the Mongo logic in the server itself.
One last question.
You kind of mentioned that you're going to push this out there in
learned from the community in terms of
Yeah.
what's important in terms of features
Yeah.
today.
Mm-hmm.
One thing that seems kind of obvious is that a lot of production deployments have a large amount of data.
Mm-hmm.
So
Yeah.
limit and skip would be quite important.
Yeah, it's almost as if somebody told me that on the email list when I sent that out. Tim was pointing out that limit and skip, which was clearly an important part of my 10 slide long demo, is not implemented yet and is probably important. And I totally agree. I just would rather I think I would rather start getting experience in a couple weeks that doesn't apply to everyone than not get anything until later. Ship and iterate. I mean, I'm not shipping something that I don't think works. I'm just we're gonna ship something that works but not for many people or not for everyone, and then pretty soon. I mean, we're talking about a matter of January release, hopefully. The main thing you need for limit and skip is, the main thing you need for limit is there's no point, DDP right now is unordered. The only reason you use limit is with sort and vice versa. And we had to write a bunch of extra logic to be able to say things like, does this modifier affect this selector? Does this field, we're doing analysis of the selector, of the field specifier, and of the modifier, and all of those are different, and all of those behave with arrays in a slightly different way in Mongo, and Slava has spent countless hours just writing test cases that show the weird ways that they interact with arrays and nulls and stuff, and we haven't done that for sort specifiers yet. That's just an extra set of figuring out, okay, what happens if there's a triply nested array, and you type a numeric key here, and this and that and the other. We're gonna do it, it's important, but we're gonna get it out without that first.
Does it not support sort at the moment?
I mean, observe is an unordered thing, so it doesn't support sort. But if you're publishing something with sort and not limit, you're just wasting Mongo's time basically, because it all loses its order when it goes over DDP anyway. But yeah.
Oh. All right, we're going to take a 1-minute break, so anyone who needs to go to the bathroom can, and we can let some folks in from the lobby over there. And we'll be getting ready for lightning talks.
So if you're giving a lightning talk, if I can have you